Hello again, everybody. Welcome to the final section of Unit 8 and the last one for the year. Today we're doing normal in reverse. So working backwards, you'll need to work backwards when you have the percentage or percentile, as well as the mean and standard deviation to find the specific x value. This can be done in calculator by using the inverse norm function in the calculator. Now, we looked at this very briefly at the very end of the last section, and so now we're going to focus on it a lot more. So the idea here is normally we have some amount and we compare it to its mean and its standard deviation to see what percentile that amount is at, or how much percent is below that amount or above that amount, right? Or between two amounts, right? We look for that percentage or proportion. But here we are going to be given that percentage or proportion, and we're going to try and find what value that is at. So if I'm like thinking, what ACT score is, the top 20th percentile, right? So then I'm going to look up backwards. Now I know the top 20th percentile is what my percentage is, but now I have to try and find out what the actual ACT score is that would match the um, top 20th percentile. So we'll see a couple examples here. And yeah, and if you have questions, you just let me know. So example number one, a set of laptop prices are normally distributed with a mean of 750, standard deviation of $60. 95% of laptop values are at or below what value? So this is very similar to the question we ended with last time, if you remember that. So let's try to focus on it. All right. So first thing I would like to do is draw out our curve again, just to create a bit of a visual for us. I always like doing that. So mean is 750. Standard deviation is 60. So 1, 2, 3. So we're going to go to 810, 870, and 930. And then we go backwards 60 as well. So 690, 630, 570. All right. So now here's the question, right? At or below the 95th percentile. So the 95th percentile, we don't know exactly where that is, right? But at or below the 95th percentile. So let's just assume question mark, that's roughly where the 95th percentile is, right? I don't know. I'm just guessing. But at or below is to the left of this, right? All this area down here. All right. So that's good news for us because we could, again, use our Z table or we can use our calculator function. But let's look at our Z table first. So the 95th percentile, if we look at it on a Z table, we're looking for 0.95. And it's right here between 1.6, let's see, 0, 1, 2, 3, 4, between 1.64 and 1.65. It seems as if both of them are equally close. So maybe we go with the 1.64 option. Maybe we could use 1.645, possibly. We can always try and gamble a little bit. All right, so let's try to do it manually first. So we know the Z score for the 95th percentile is 1.645. So 1.645 is equal to the X value that we're looking for minus the mean, 750, divided by standard deviation of 60. So if we solve this by hand, we would, of course, multiply by 60 first. Cancel that out. Let me grab my calculator. We have 60 times 1.645. So that's on the left becomes 98.7 equals X minus 750. So then we just add 750. And so adding 750, we get 848.7. So by hand, this is our best guess. 848.7 is the price of laptop where 95% of prices are at or below that cost. So 95% of laptops cost $848.70 or less. All right. So now let's do it using the calculator to see how close this number was. All right. So let's set it up there. We would use the inverse norm function. So that's what we're going to do. So let me show you that. So again, you're going to go to second vars and we're going to go to inverse norm. Now remember, I mentioned this briefly last time and I'll say it again. A newer calculator with a more updated software has this tail option here where you can choose left, center, and right. But most calculators, especially the ones in school, don't have this option. So they default to left. So I'm going to do it based on if it was default anyway. But anyway, we would also do it to the left regardless because we wanted 95% or less, which is to the left of 95%. So yeah, because it was at or below, that's to the left of 95%. So it works kind of that way anyway. So the area is of course 0.95, right? 95th percentile. The mean was 750. And standard deviation was 60. And again, keeping it left, and paste this. We get 848.69, basically 848.7, like we had estimated. So pretty darn close. So, all right. So yeah, you could definitely do it by hand. You can also use a calculator. Either way works. Let's try it again. The store sales have a mean of 66,000 and a standard deviation of 22,000 and approximately normal. Departments with sales in the top 8% receive a reward. What is the minimum profit that department needs to get the reward? All right, so again, let's kind of draw it out. All right, so the mean is 66,000. I'm just gonna put 66. The standard deviation is 22. So if you add 22 each time, you're gonna get 88. $110 and 132. If you subtracted 22, you'd get 44, 22, 0. All right. Now, top 8%. Think about that, right? Top 8%. Top 8% is going to be on the upper end, right? So top 8 would be over here. Somewhere on this right side, right? We'd go to the right side, top 8. Now, top 8, though, also, right, is the same thing as separating the lower 92, right? Lower 92%. And that's going to be helpful for anybody with one of those calculators from school, because the lower side is 92%, the top side is 8%. But again, because most of the calculators default to the left, you're going to have to use 92 instead of 8. So I'll show you that real quick in the calculator. So again, we go to second vars, we go to inverse norm. And now, if you have a standard calculator from school, you're going to use 0.92, not 0.08. Right? Yes, it is top 8%, but remember, top 8% separates the bottom 92%. You understand what I'm saying? 92% to the left, 8% to the right. Mean was 66,000. Standard deviation was 22,000. And then again, because all your calculators default to the left, we're going to leave it as left and solve it. So we get 96,911, basically. So 96,000. Let's go back to a different color. I don't know if the change is going to matter necessarily here, but if you did include the change, it would be 57 cents. All right. Well, the allergies are really kicking my butt right now. All right. So let me also again demonstrate. If you did have a newer version of the calculator, like the one I'm showing you here, you can actually switch it. We can actually put in 0.08 if you have the capability of switching it to the right tail, right? So we're saying 8% to the right instead of 92% to the left. If you have the option to choose right, you can do 0.08 to the right, right? That again, that means top 8%. You see it's the same answer, right? But again, if you can't choose right, then it defaults to left. So you're always going to have to think, no matter what, to the area to the left here. Now, just again to show you guys how to work this one by hand, here's how you would do it. So top 8%, let's go to the Z table, top 8%. So we're looking for 92 percentile, right? 92 percentiles, where the top 8% would be 92 percentile. Right here's the closest, 9207. And that's at Z score 1.41, right? Because that's 1.40, this would be 1.41. So Z score would be 1.41. And that's, close because not exact. Equals X minus the mean. The mean again was 66,000. I'll just put 66 for now and divide by standard deviation of 22. All right, so when you solve this, you'll multiply by 22 on both sides, and then you will add the 66 to both sides. So multiply by 22, and we get, let's see, 22 times 1.41 is 31.02. Things always spazzing out on me. 31.02 equals X minus 66. So then, of course, we'll add the 66 and get our final answer. So add 66. We get X equals 97.02, which again, remember, is in the thousands. So that really means $97,020 basically. Oops, come on now. $97,020. So again, you can see doing it by hand is a little bit off. And the reason why it's a little bit off, so this is a little less than 97,000. This is a little bit more. The reason why we're off, this is going to be more reliable, the one on the calculator, but yeah, the reason again why we're off is because on our Z table, remember, we're using 9207, not 92 exactly. So it's really, 1.40, 1.41. It's really somewhere between those two. So it's probably 1.405 or something like that. If we did it, if we use something in between, we'd have a little bit more accurate. But so doing it by hand can get us obviously pretty close, but maybe not exact. So using a calculator is obviously the most, what do I want to say, accurate way. All right, and then finally, one more. For a normal model with a mean of 25 and standard deviation of 2, find the X value to match the model. All right, so we got two of them here. So we have 0.630. Let's just use the calculator on this one. And that's 630 to the left. So we'll go second bars, inverse norm. 0.0630 is what I think it said. Yep. And again, the mean was, what did it say? 25 and standard deviation of 2. Let's double check that. Yes, it did. Okay. So again, we got to switch to the left. Because you can see for one, the area is to the left. But anyway, even if you have an old calculator, it's going to default to left anyway. And then paste. We get 21.94. So this first one, 21.94. If we do it with this one, 29.81. So remember, let's think about what area is to the left here, right? 1 minus 0.2981 equals, let's see here, 7019. So 0.7019. All right. So this is the area to the left. This is the area that you would use in the calculator. So if we go back to this again, second inverse norm, we can use to the left 0.7019. Same mean, same standard deviation to the left. Go ahead, paste it. We get our answer 26.06. But remember, if you have one of the newer calculators, of course, you can put 2981 into the right. So just again to demonstrate, because it is to the right, if you wanted to, you could do 0.29. What was it? I forgot. 81, I think. Yeah, 2981. And then switch it to the right if you have that capability to switch it to the right. So this could also work if you have that ability, like I mentioned before. So same answer. But again, most calculators don't give you the right to choose left and right. So it defaults to left, which again, so most of you will typically have to think about, well, hey, this is to the right. I can't use that. I have to figure out what amount is to the left here and use that amount. And then finally, the mean weight of adult American men is 180 pounds with standard deviation of 25 pounds. The weights are normally distributed. What is the minimum weight of an adult American man in the top 10%? All right. So again, let's graph it. Always like visuals. Mean is 180. Standard deviation is 25. So we got 205, 230, and then 255. And then backwards, we have 155, 130, and 105. So top 10%, it's going to be somewhere, I don't know, somewhere to the right, correct? Top 10%. But remember, top 10% means the bottom percentage is 90%. So when you're using inverse norm, again, think to the left, and the top 10% really translate as well to lower 90%, right? So when we go to inverse norm, we're going to have to think about that. So inverse norm, bottom 90%, mean 180, standard deviation 25. We go switching it back to the left, which is default anyway, and then paste it. There we go. 212 pounds basically. So probably put my mark in the wrong spot. 212, about there-ish. So top 10% mark cut off at 212 pounds. There it is. So I didn't work that one out by hand, but I did the first two. I did them by the z-scores. So just to show that you can do it. But at the end of the day, you're going to have a more accurate result with the calculator. So you might as well use that anyway. But yeah, if you guys have any other questions, you just let me know. But that's going to be it for Unit 8. Now, time to look forward to our test and our final exam. I'll see you guys in class for that. Bye for now.